All right, hello everyone. Welcome again to ECS 179 Gameplay Programming. Today, we'll talk about game mechanics, rules, and systems. So this goes along with a reading by Miguel Sicart, which you can see as soon as I bring it up. Right here, Defining Game Mechanics by Miguel. And later in the week, we'll be talking about the pub sub patterns. So those are the two readings for the week. And here's a link to exercise 2 camera control, which we went over in discussion today, which we'll talk a little bit more about. So the reading is an in-depth look at one person's perspective on defining game mechanics. It was a seminal work in the game studies field in this particular area. We're going to go a little more broad today, and we're going to talk about game mechanics in a definitional sense and an ontological sense, as well as show examples and talk about how that impacts play. Now, today is a little abstract. Today will feel like game studies. This is setting the foundation for us to build better gameplay systems with technology. So, as we discussed earlier in the class, this class runs through an iterative loop of talking about design and understanding game design, and then building the technology to make that happen. So every time we become more nuanced with our understanding of game design, we can be more nuanced with our technical approaches. And when we build a better technical base, we can then refine the design. So an iterative design loop, which is also an instructable bit about this class, as this is how games are designed and developed as well. All right, who's played Cornhole? Right? Did you know there's official Cornhole rules? You probably did, because it's more popular now, and there's like tournaments and stuff. It's, I don't know, like Cornhole was what pickleball was. How many of you played the Teenage Mutant Hero Turtles card game? Probably none of you. But this is also a game with pieces, with rules, with the ability to play, with objectives, right? So we're gonna, because there are these written things, rule books and rule sheets, but then there's also things like how high can you jump? Can you move through walls? All these are the things we deal with, the ludic parts of games, the mechanical parts, the rules parts, the things that define their structure and the possibilities to play within their space. So we're going to delve into some of these and put some more rigorous definitions behind what we think of in game mechanics, rules, and systems. So this will help us build ontologies, will help us build a representation of knowledge, will help us build the foundational understanding that we need to better implement and segment off design documents into technical artifacts. So this is about building your understanding. You can think of this, what we're talking about today, to game development. The analogy is that's the same thing as relational calculus to databases, right? We're building the underlying logics and motive principles that inform our implementation. All right. So you may have done the first reading for the class, the rules of play reading, where we'll pull these early definitions from. So rules are the formal structure of play. They're a defining quality of games, but they aren't the experience of play. They aren't play itself. Play exists outside of rules. Potentially. They are changed and modified. They changed to modify the experience of play. Meaning they're not real life, right? So often, particularly with children's games, you'll have a set of rules that evolve, like, you can't double stamp a triple stamp. What's that from Dumb and Dumber? We have a bunch of rules about riding shotgun in a car, or who can use the remote first, or whatever. Who gets the control of the Chromecast, right? So there's not etiquette, law, or social rules. They are the ludic rules. They are the things that guide our behavior, the things that we self-impose that are external to our social lives, that are external to the real world in some sense, which makes them foundational for the space of play. So what do rules do in games? Limit player action. They're explicit and unambiguous. They are shared by all players. They are fixed. They are binding. They are repeatable. And as people like to do, people like to break them as much as they can. At this point, I want to give you a little warning. You may want to get out your phone or something that uses Discord. We'll be using it in a moment in class. This is from Rules of Play, this definition of meaningful play. So play can be frivolous, play can be superficial, but play can be meaningful as well, and meaningful play is what video games are largely based on. So meaningful play in a game emerges from the relationship between player action and system outcome. It is the process by which a player takes action within a designed system of a game, and the system responds to the action. The meaning of an action resides in the relationship between action and outcome. So what does it sound like to you, computer scientists? Input to output? Mappings? Functions? Systemic results? This is a very system-heavy version, which lends itself well to concepts we've learned in computer science. State machines, rule-based systems, databases, conditionals. All these have their place and are good training for thinking about game rules and game logics. This is a game like we used to play in class when we had bigger spaces and a better room, but it's a lot. So we're going to get on Discord. Hey, Kyle.
Hey, Josh.
You're up. Kyle's gonna start the game. Kyle's GM. Kyle is the first game master. So what Kyle's going to do is Kyle's gonna think of a game title. And Kyle is going to post it in the general channel in our gameplay programming category on our class Discord server. Now, you are all players. Now what you're going to do is react with whatever reaction to that game title you wish. And you can also click on other people's reactions. So when you're the first to place a reaction and other people vote on it, we'll get some scores, we'll get some tallies. The person who first put in the reaction that gets the most tallies, gets the most votes, gets the most reacts, will be the new GM, and they'll get to post the next title. And then we go to 1. All right. I will not record or stream this part. I won't record actually Discord as it decides to update. So are all of you seeing the title? What was it, Kyle?
The Game of Games.
The Game of Games. Let's see what we have here. Come on. All right, we got tallies coming up. We got ups and downs. Someone jumped the shark with Sonic. That's okay. All right, I think we have a clear winner. All right, someone posted nerd. Aww. That's rich in a computer science class. Someone's got some chutzpah. All right. Who did it first? Who was the one who posted? All right. Next, you get the title. Post a game title. God of War PS4. All right. React away. Right, the basic axe is pulling a heavy lead. There's no fatherhood icon. No Kratos crayfish. All right, who did the axe? Who was the axe responder? All right, excellent. You're up. We're just gonna do another round or two of this. Tekken 8, bold choice. Skull. All right. Oh, is the punch going to take over Skull? No, punch is out of juice. It's just mid punch. I don't know. Oh, Skull's going down. Skull's going down. Punch is going up. Oh no. Oh no. There is more than one punch. Wow, what a shocking turn of events. All right. Who's the punch? Who did punch emoji? Punchy mode, yeah. All right, you're up. FIFA 17. Oh. Like 17, like going 17. Get the deep cut. Do what?
The older one's so much better. The older one's
Yeah, you got to get to the 17th series. The 17th entry to series is the sweet spot, right? Yeah. Not the 25th, not the 5th. 17. All right, are we gonna let Saab stand? All right, so who was our final winner here? Who did Saab? Excellent. Well done. You captured the Geist of the room for FIFA 17. Excellent. Well done. All right. So, I present to you here the rules of the game. What do you think about them? Did they work? What did I do that was implicit that wasn't in the rules? How could you make this go awry? Yeah.
Well, for one thing, you mentioned, oh yeah, it looks like the punch is coming, and immediately people sort of unclick on the emoji and start going for the punch, which in essence you accidentally triggered the game.
Right? I simply made a comment and we changed the momentum potentially. Right? So there's external forces. So we had a whole other channel of communication that isn't specified or mitigated or mediated by the rules. Yes. Exactly. There's no defined end to each turn. I ended them arbitrarily, and there's no defined end to the game. Go to one ad infinitum. What else? Yeah.
Groups formed based on how people felt about the game.
Yeah, there's an emergent property here, right? Of who emotes first, how the emotes factor into the room. Typically, the first one is done pretty darn well. There's all sorts of other effects that go on here. Right, so as a set of rules, they fit on a slide. And in this sort of situation where I'm here to be the meta GM, to manage the process, the flow, it works, right? But if you just put this on a card and put it in a bar, it would not work, right? So, there's some flaws in this. this isn't a well-defined, rigorous set of rules. This is one that I made up before class a couple years ago, and we've done it a couple times. It hasn't changed since then. I haven't modified it. But it serves as an example, right? A quick design that we can then talk about and iterate on. So what would you do to make it better? What rules would you change? What would you modify? Yeah?
I would hide the amount of reactions so that everyone chooses what they choose and not the mob rule.
Yeah, that's true. Yeah, so you would just have the reaction shown without numbers, but people could see just that there was a react of that type. Because we do have to have some way to aggregate, right? Yeah, so I mean, that's a systemic thing, right? Where would that be in the rules? Like, how would you modify the rules to do that? You're talking about modifying Discord message, right?
Don't use Discord.
Yeah, don't use Discord, right? The medium could be the problem. What else? Yeah.
Like to guarantee that this certain emoji will double up or stack up, like very much limit to like a maybe just like a base set of emojis, because if not, if like an unlimited or more emojis than there are students in the class, it's very likely that you're not gonna match up.
Well, yeah, so you can click, so there is no limit on what you can click on, right? We could max out the emoji count, right, for a particular thing. People could make their own. There's no rule for what ties, tie breaking, right? So all these things you mentioned matter. And if they are hidden, who reveals the information? Where in the rules does it say that someone has privilege to see the count? Right, so there's all sorts of cascading consequences and things managed implicitly. So part of building rules for games and making them work is taking that explicitly found material and codifying it, handling it, designing around it, implementing a rule or set of rules or a system that handles those consequences. And these are pretty tame emojis. Like, we got nothing R-rated in here. I'm impressed by all of your restraint. Mechanics. When your car... No. Okay. Game mechanics are methods invoked by agents designed for interaction with the game state. Defining game mechanics by Miguel Sicart. So this is a definition that when you read the reading for today, which I'm sure all of you have done already, right? I'm sure if I gave a quiz now, the results would be excellent. So you're well prepared for this. This is a very agent-based definition. This fits well into the world of computer science and digital games. Methods, agents, interaction, state. All very digital. Here's another version. The guts of a design document. What the players are able to do in the game world, how they do it, and how that leads to a compelling game experience. So, how would you contrast Roos's definition of game mechanics versus Sicart's? What's important here? First, what's important here? What is the contrast? Where are the metaphors coming from? Yep.
The first one felt like you mentioned it felt very computer science, and this one I guess also feels more like artistic or like more abstract, and like it feels like a game world that I'm doing stuff anyway.
Yeah, this is phenomenological, right? This is coming from art and experience as opposed to structure. This is the felt consequence as opposed to the structure. Mechanics describe the particular components of the game at the level of data representations and algorithms. Mechanics are the various actions, behaviors, and control mechanisms afforded to the player within a game context. So what about this one? What does this emphasize that the others haven't? Ooh, we have to go around the room humanity style? The classroom's too big for that. Yes.
It explicitly mentions data and algorithms.
It does, right? It also brings it into this level of actions, behaviors, and control mechanisms, right? So we're doubling down on the agent-based methodology. So this is getting into classic artificial intelligence terminology for believable agents, for belief, desire, intention models. The language is similar. It's from more of a cognitive psychology background. Afforded to the player within a game context. This idea of affordances is a very particular way of seeing games, coming from a particular branch of social psych. So what that means is now we're putting the emphasis now on the psychology of an individual interacting with a system. But we're also leaving room for bit representations, for numbers, for locations, for data structures. The means to guide the player into particular behavior by constraining the space of possible plans to attain goals. Game mechanics are best described with verbs. All right, what does this do now? How is this different from the views we had before? Does it have more common with Descartes, with Roos, with Huneke et al.? Let's go with Zubek. I like Zubek better. What do you think? You have a hand? Yeah.
So, like, one of the earlier definitions talked about, like, what the players can do in the game world, which feels very, like, liberating. Well, this one is more focused on the constraint that's put on by the rules. Is that, like, an opposite approach, or, like, direction in that way?
Yeah, would anyone care to comment on or follow up on this idea of this being the inverted version of other mechanic definitions we've talked about? Yeah.
And so the other definition, like you were saying, it was like affording the players. I'm giving the player options versus this is I'm limiting their options. They're not allowed to do whatever they want.
Yeah, so one's like a positive interpretation, one's a negative interpretation, right? Negative color spaces versus additive color spaces. Here, we're seeing the world of possible play. Here, we're seeing the world of possible play as function of rules. Here, this script is flipped, right? We're seeing the world of possible play as just about anything you can imagine, and then we're drawing a circle that, of all that big possibility space, we're drawing a circle for you to play in, right? But we're not limiting you to game design verbs and actions. This is more like tabletop, or, the, I don't know, your parents playing Monopoly and like bartering and negotiating with each other, right? That's a different style of play. That's, you're there for capitalism ho, right? You're there to get as much money as you can, no matter, however you can make it happen. But a lot of things that happen are well outside of the game rules. Trading, bartering, making deals, sliding fake bucks under the table. All these are not specified in the rule set. So are you seeing things as totally prescribed by the rule set, or are you seeing just a very light border around a space of possibility? Game mechanics are rule-based systems/simulations that facilitate and encourage a user to explore and learn the properties of their possibility space through the use of feedback mechanisms. All right, what do we have here? another take on possibility spaces, right? But how is this distinct? What does this add to our conversation? Hmm? Right? So there's a lot of learning style language here. This is, Cook's work, which is pretty well known for procedural content generation, right? So looking at things as possibility spaces and finding samples within that possibility space and having players sample, explore, and learn a lossy representation of perhaps even a hidden or obstructed ludic core or set of mechanics, having them learn the interactions, the dynamics of that space, how the mechanics interact with each other. Having them learn that through play is part of this discovery process, part of the discovery of play. So we have all these definitions of mechanics, and they're pretty varied, right? There's really, games are complicated artifacts. We don't really have a solid definition for games, much like we don't have a solid definition for artificial intelligence, right? Game mechanics are really, you can use about any of these definitions depending on which type of game or which type of project you're working on. Some are better for sim and exploration and open world games. Some are better for board games. Some are better for tabletop games. Some are better for card games. Right? So it is really incumbent upon you as someone who would interface with a designer to understand how they are seeing mechanics when they create their documents, when they create their games, when they create their playthroughs, their play traces, their paper prototypes. You need to understand the metaphor through which they are seeing mechanics and adapt your system implementations, your descriptions to help encode, to make procedural their way of seeing the world. Because it's really the designer's vision that you as a gameplay programmer are helping to bring about through play. You're digitizing a human object. You want it to have the same human, social, and cultural relevance. You want to preserve that artistic intent that the designer has in your implementation. Which is why we did this fuzzy look and conversation on a bunch, or 5, definitions of game mechanics. It's tough dealing with other people who aren't technical and making their vision happen, right? This goes well beyond someone being like a producer or whatever that term is in Agile, the consumer, the person who pays the bills that wants your artifact. Designers, usually the ones that are trained and well-read, they will know these definitions and they will know which metaphors are best for their games. And so it's incumbent on you as the gameplay programmer to know them as well, to help translate. Systems. Chris Crawford. A game is a closed formal system that subjectively represents a subset of reality. A game world. Super Mario Brothers. Classic example. Let's see. Prince of Persia. The Lost Crown. Has anyone played it yet? It looks like it's going to be contender for Game of the Year already. And it's January. It looks like it's changing that genre to a Metroidvania. So it is also a game that is a closed formal system, right? It's bound by conventions of, first, the history of Prince of Persia games, starting from Jordan Mechner, Prince of Persia, 1989, all the way through this recent title in 2024, and also including all the cultural assumptions based on the Jake Gyllenhaal starring movie. What is it? I even forget what the title of it is, but that is also entering the conversation. That's in the zeitgeist of how people understand the Prince of Persia game. But the formal rules of the system are combat, are discovery, are medallions. It has a souls-like campfire system, trees in this case, that you unlock, and when you die, you go back to the tree. You can reset your medallions in this game, or your ability to customize your gameplay right there at the tree, right? All of these are closed formal systems. They're different from reality at whole. You don't die and come back to a tree. You may become tree in the long term, but powering yourself up medallions, traveling through a time-lost mountain that's partially prison. All of this is a subjective representation of some stylized version of our history, of our reality or imaginary. So game systems, in Crawford's definition, help us through our implementation of designers' mechanics into rules or sets or systems of these mechanics brought together, help us build a fictional world, help us build an experience. They lay the foundation. When mechanics are woven together into systems, they represent things. So the magic circle, I'll leave this video for you to watch since we're running around. So the magic circle is this idea of having this circle of inviolability, where when you're inside the circle, you are like in the game world, you are immersed. There's no breaking the fourth wall or talking to the audience, right? The magic circle is this, within this space, there is play. There is the game world. And you can see the extra credits video on that. It's an interesting take. But there was also this idea of formal elements. So what are formal elements in this case? Well, they're really handy for us to know about as gameplay programmers, because these are the things we will be encoding. Objects, the elements in the games, the variables, the parts of a system. They can be physical, like power-ups, pickups, coins, stars. They can be abstract, like an insanity meter in Call of Cthulhu. All the relationships in the Persona series. Attributes. There are properties and qualities that a system and objects within a system can have. Strength, wisdom, vitality. All of these are attributes that play across mechanics and through systems. Internal relationships. Objects that are internally connected to one another. So we have things like keys opening doors. We have the location of a key card being conceptually linked to puzzle solutions down the road. The environment. Well, this is what everything's placed in. Subjective relations, environment, environmental storytelling, weather, mood, lighting. All of these things color the interpretation and situate gameplay for objects with attributes and internal relationships. Play with formal systems. Playing a game is the voluntary effort to overcome unnecessary obstacles. Right? So in a lot of these cases, formal systems, any sort of rule, as many libertarians will tell you, is an abridgment of freedom. Right? Anything that restricts what you could possibly do with your world is an obstacle. Well, I mean, even children do this, right? They play store, they play shop, they play dolls, they play Barbies, they play G.I. Joes, they play whatever toy, they play Bratz, I don't know, whatever toys kids play with these days. But they make up rules for each other. They make up what you can and can't do. Tag is a very popular one, hide and seek, right? All of these are obstacles that don't really exist in the world that they are making up out of thin air to facilitate play and fun. So the cynic take is overcoming those unnecessary obstacles. Turns out, rules can be fun. Obstacles can be fun. Obstacle courses, those are fun. So common systems. So let's put some things on here. Territorial acquisition. So these type of games that have these type of systems are often zero sum. There's a limited amount of territory or resource. The game like Risk. Or if you've ever played the line game, or Go. Go is a great example of this. Prediction. You often find this in party games or gambling games. Often luck is involved. Does the person have, a flush, a straight? Two pairs? Roulette, right? Roulette is very luck-based. Spatial reasoning. How game pieces situate together. Tetris. There's one great design video. I'm sure you've all seen this. Goes in the square hole video, where there's all these pieces, and there are arches and circles and everything, and they all just happen to fit within the square hole. This goes around game center circles a lot. I'm sure you've seen this. We'll look at it. I don't have it queued for today, but maybe we'll do it during lab. Survival. I'm sure all of you played survival games by now. Rust is a ubiquitous example. Destruction, building, collection, chasing, evading, trading. All of these are types of systems. And in a lot of particular AAA games, a game consists of multiple layers of these systems together for its larger gameplay effect. Can you think of a game that has multiple systems working together like this? Probably any game. Name your favorite AAA game. Who has an example of a game that has a couple of these systems in it? Yeah.
Yeah, Minecraft has a survival system, and it also has like a destruction system,
Mm-hmm.
and also I think building system definitely, yeah, and also I think there's like a territorial system because you need to like there is like a potential PvP system inside Minecraft.
Territorial system, yeah.
Yeah, you can fight with others, gather things. I know like some servers does that, like you have to fight with each other to like gather things to, yeah.
Exactly. Does Minecraft have it? Territorial acquisition. Does Minecraft have it? Does it? Ish. Prediction. Are you trying to dig down and basically using the procedurally generated world to see if there's like the resource you need in a layer? Right? It's got that. Spatial reasoning. Does space and configurations, does that matter in Minecraft? Yes, it does. Survival. Is Minecraft a survival game at night against the creepers? Right? Destruction, building, collection, chasing, evading, trading. So Minecraft is one of these games that has just about every major system integrated in some way, and if it doesn't exist in the base game, someone's put it in, right? Someone has modded it, put it in. So Minecraft is like this example. All right. So this is not what we're talking about with systems. We are not talking about the layers of technology behind a game engine that provide the substrate for any game to work. Just a caveat. But there are basic systems that are a little smaller than the ones we've talked about that are composable. Moving and shooting, picking up, commanding, building, capturing, transforming. So systems work at various scales, such as the Dragon Quest VIII vocational chart. Have you played the Dragon Quest series? Oh, I was expecting more. Okay, fine. So there's a system of classes in the game that you can traverse, and then you can pick up special items throughout the game and enhance your class, particularly the Sage being one of the more important classes in the game. What's this one? Who has seen this before? Right, this is the Pokemon Elemental Strengths and Weaknesses chart. This is a game system, right? This is a system of effectiveness, of cross-effectiveness, of weaknesses and strengths. Turns out this idea was super effective. It worked very well. Many games have done this. Pokemon was not the first. But it's one that had a sufficient cast of characters, of collectibles, of critters in the world to really make a chart like this shine. And they even like somewhat preserved it in Pokemon Go. It's a little weak. The systemic attributes of Pokemon in the particularly the first two games were very strong, very, very classic JRPG. Does anyone recognize this? This may be a bit of the before time. In the golden age of massively multiplayer online role-playing games, there was Final Fantasy XI. Sorry?
The original one or the remake?
You're thinking of 14.
Wait, was that one was remade?
Yeah.
Wasn't 11 also like cancelled and then remade?
Nope, that was 14. I played the beta of the original, and then it was really bad. And then they reborned it. And so the first the base game is called Final Fantasy XIV: A Realm Reborn, right? Where you have to sit through a lot of story to get to the good stuff. But this is from its predecessor, Final Fantasy XI, which certainly is harder to play now. But it had one of the most intense, intricate combat systems of any game I've seen. This is one system within many. This is the Ranke chart, the ability chaining chart. So each class had special moves that you built up through tech points or spent a resource to use. Right? And the idea here was that each of these skills was associated with some sort of element or power. This chart has all of the skills listed, but also has these arrows. So going from, so we have darkness, light, archery, fusion. So if you went from one of these, like this skill here, and you followed up with a skill in this category, you'd have a distortion. And then you could follow up one of these with a darkness skill, or and follow it up with one of these skills and get a darkness skill. Let's see, it works a little better here. So we have lightning followed by fire. It's called liquefaction. But you can also have lightning followed by wind, which would be detonation. So this chart is really big. We're just seeing the first top chunk of it. Now what you could do is in combat, enemies were very strong. Even the basic enemy a single player could not defeat on their own. Everything had to be defeated in parties. You couldn't get XP from anything you could kill solo, except for one class. So that means you had to really strategize even to beat basic foes. So here, part of the strategy of the game was to coordinate your team's attack skills to have an attack happen, and within a certain time window, have a second attack happen, which would cause one of these effect bursts, like a light burst, or a distortion burst, or a gravitation burst. And then you'd follow it up with another one, which add another multiplier burst on top of it. And so the more of these you change in the row, the higher the burst damage was. So this is the basic ability chaining chart. Now on top of that, each one of these bursts, darkness, light, fire, wind, were associated with an element. How many of you know of the Black Mage in Final Fantasy? The hat, straw hat? Skills like fire, Fire Aga, ice. All of these were elemental skills. So if you timed your spell cast, which could be as long as 9 seconds, if you had timed those right so they landed within like a 2-second window of one of these bursts, you would get a special magic burst on top of it, which was extra damage on top of that. And so this is how you became very efficient at the game. It was a choreographed, multi-skill, 30 to 60 second dance that everyone had to compete on in unison. And this was before voice chat. Like people were just like using TeamSpeak, which you may have never heard of, right? Before this. This is before Ventrilo. People were probably calling each other on the phone, except they couldn't because they were using dial-up. Right? But these sort of intense gameplay systems, meticulously designed, used to be a little more par for the course. So seeing this as a design artifact is quite interesting. This is a system on top of mechanics on top of systems. It's a beautiful thing. Yep, speaking of Minecraft, this is a visualization of crafting in Minecraft. You can see the GitHub repository for the project below. Now you can actually load up your own Minecraft instances and see, you load in your own game state here and get your own customized crafting chart. So this is a 3-dimensional graph-based visualization of crafting. It's a complex system. I mean, you could even see like the potion creation in Minecraft as a system of its own. And then, so this is layered system on top of systems in a hierarchical way to have a pretty darn interesting, almost procedural-like outcome from all this, even though it's all designed. It's designed with such a complexity that it almost feels like freedom. Kind of like Baldur's Gate 3. Smash Bros. Who wants to work on their Punish game? Well, you do that with short hops, right? So here's an analysis. This is like 3 years old now. This is the best visualization I could find from a Reddit post from like 3 years ago. Analyzing the current Super Smash Bros. Melee jump height, short hop height, the difference between the two, percent difference. So you can see what characters are strong and weak against each other in the jump game. Anyone see the video that came out like 4 or so days ago about the the temple jump and Mewtwo? Yeah, interesting. So there's all sorts of analysis here on the jump and the jump systems. So this is a player-facing artifact. The reason I bring this up is players interact with these artifacts, and that's the primary concern. As Roos put it in the definition of game mechanics, dealing with these systems and internalizing them and playing with them and figuring them out is what theory crafters do. That's one of the fun parts, one of the fun places to play. Everyone theory crafts to some extent when they're picking skills or when they're just playing the game. You have to choose what you're doing in some way. So you build some sort of model on how the game works in your mind, and you try to predict what actions will go well for you in the game, choose and play. So some people take it to a bit more extreme places than others. Like me. This is my log from my raid last week from the latest raid. This is the boss, Igara. On the left, my log from Igara. So you can see my breakdown over time of my damage and each skill taken for my Outlaw Rogue. And so you can see, this is from Warcraft logs. So you can see the breakdown over time of how much each one of my skills contributed to damage. Now, the way you get better at this is by analyzing what you're doing. You see how your log compares to others' logs. And there are systems to do this, like lorgs.io, right? Where you can go through and see, of the top parses of the fight, who uses which skills when on a timeline. Right, so you can take these little systems, the boss systems interacting with your equipment systems, interacting with your ability systems, interacting with these external meta systems in order to enhance and make a different space of play. And so this is Tindral Sage Swift, one of the more fun fights from the raid, not Igara. So these are two different bosses. The Tindral one was just funner to see on the timeline. We talked a lot about mechanics and systems. There have been some academic studies of the depth and breadth of these. So here is a breakdown from one of the survey papers in this space about mechanics. I think there's a lot to add here. I think this was not looking at much of the, particularly digital games, not looking at the totality of game mechanics, which would probably be a fairly impossible task. There's such a varied notion of game mechanics out there that making an ontology could be impossible, but here's one that you can reference and maybe learn a bit from. It's good, just like when you're dealing with the designer and seeing what perspectives they use to analyze the world and the mechanics and dynamics and systems. Here you can see what academics bring to their perspective on this. So the way they see the world, the subjective lens that they bring to building an ontology of this space is important. I won't share the main storyline with Suramar. That's fine. We already talked about WoW enough. I want to give you some resources to delve a little further into this. So here are several talks that I quite enjoy from the Game Developers Conference, which happens every year in March in San Francisco. One of the premier industry conferences. I encourage you to go to it. The student day is on Friday and it's relatively inexpensive. It's great. You'll meet a lot of cool people there. The talks are quite good. It also costs like $2,000 to get in to see them, but they're usually online. The better ones usually are present for you to see. When spreadsheets and flowcharts aren't enough, how to design. There's this machinations tool for building game mechanics for the visual metaphor, visual programming. There's just so many really interesting talks here. I encourage you to go through and like take a look at these sets of resources on the slides. We don't have time to go into all of them, but there's just a lot. This one I really like, 5 techniques from quite inventive designers. This is just a knockout list of really interesting people to listen to. We saw Richard Roos III, very popular game designer, gave us one of our definitions. Liz England, Emily Short of interactive fiction fame. Some of the best of. So I highlighted this video in particular. There's other ways of seeing this through the lens of humanities and game studies. This book, Unit Operations, refined into operational logics, is sort of an academic or studies take on this, where you can reflect on the systems and the more abstract attributes and philosophy and combinatorics and logic underpinnings behind game systems, building them up from the bottom. There are a few interesting artifacts here. Particularly, I'm fond of Kaboom. Is a many-splendored thing, an interpretation and design methodology for message-driven games using graphical logics. This is a joyous paper. It's one of those academic papers that's fun to read, where it breaks down on the scale of what happens when a circle collides with another circle and one of them disappears. What little bit of meaning does that make? And how, when you interpret a game from those small units of meaning, how do you make larger meanings happen? A deep reading on solitaire, order fulfillment games, Burger Time. So I focused on Mike Trainor's work here because I find it quite interesting and joyous, and he's very much a friendly. Was from UC Santa Cruz. Was in my lab, so all sorts of interesting stuff. I was in the lab with him. If you're interested in going deeper into this interpretation and game studies, here is a really interesting route for you to follow. All right. We have 15 minutes. Any reactions to the presentation? Anything you want to see? Any comments to make? Did your brain stretch in a way you didn't think they would stretch today in a computer science class? I hope so. All right, there's a couple things I want to show. So how many of you have not seen the discussion section for today describing exercise 2? Okay, so most of you have seen it. I'm getting a lot of no response and some vague head nod yes, and maybe like 4 people who said no. So I'll just go forward. This is the basic version of the project, right? So I covered the code you need to know, the structure of the project. I covered each one of the stages in the recording. It's on the YouTube playlist. It's in the Google Drive folder. Check it out. One caveat, I goofed a bit. When I was describing it, I had one of the old key exercise descriptions open. And so you'll definitely want to look at your exercise description. I was like flubbing over myself, wondering why I had these typos and why the language was so bad when I knew I had fixed it. Well, I just had the wrong tab open in my browser. So the description that you will see is much more succinct and understandable and has many less typos than the one you'll see on the video explanation. So just keep that in mind. Yours is better. The content is still the same. The goals are still the same. The key still is effective. All right. So some things I want to cover, particularly, is the terrain generation system. All right, so here we have a terrain generator. So notice we have this PCG terrain. Why do I call it PCG? Does anyone know what that term stands for? Yeah? Procedural Content Generation. roguelikes, Diablo, the world of Minecraft. All of these are procedurally generated. And in particular, we are generating a mesh. So a set of vertices connected by edges, which 3 vertices and 3 edges make a triangle. We're interpreting a color or a texture on top of those triangles. And this is a large set of those. So if we go to the PCG terrain and we flip it, you'll see that it has variance. This way you can see it. This way you can't. This is a computer graphics thing. This is a one-sided mesh. Now, inside of this, inside of the terrain generator, I guess first let's start with the player controller. And I will open up the code editor here and put it on the correct tab. Let's go and put it player controller. There we go. Let's resize this thing. All right. So we have our, I see what's going on here. You opened in the wrong window. So we have our player controller here, which we talked about. The key thing we want to talk about here is when Fire 1 is pressed, we go to the generated terrain and we call change terrain height. So change terrain height is a function inside the terrain generator. So here is the terrain generator. It requires that the game object has a mesh filter and a mesh renderer, so we're giving it information to draw a 3-dimensional object, this one-sided large polygon. Number of vertices, the width and height of it as stretched out. So in the base case, there are 250 vertices along the X and the 250 vertices along Y, so we have 250 squared vertices in the entire mesh. It has a big unity width. It's 10,000 unity units by 10,000 unity units, which is why it's relatively big when you fly over it. We wanted a worldish size thing. And then we have things noise scale, amplitude, frequency, and the minimum height and width of the texture. We change all of these. These are public floats, right? So we can change those inside the editor, which we do. We have an array of vertices. This is where we keep the vertex information. And then we'll end up passing it to the mesh. So when on awake, so when the script starts, we create a new array of vertices. So we take this as a one-dimensional array, and then we interpret it as triads of edges, which make a triangle. And then we call this dot generate. So this actually does the procedural content generation. So we make a new mesh. You've seen meshes. Meshes are components we put on Unity. You've seen the cylinder mesh. You've seen the square mesh. Maybe perhaps the sphere mesh. We've used these in Unity before. They're the basic 3-dimensional building blocks that are present in Unity. Well, we're going to make our own mesh. So we get a mesh filter, which helps us use the mesh information and present that to the screen to send to the mesh renderer. We have our vertices, and we have this thing called UV. Is anyone familiar with UV mapping? Can we explain what this is? Do you know how to explain UV mapping, or
Well, it
other?
basically maps where a texture coordinate would be based on the distance of the mesh.
Yeah. Did you want to add?
Yeah.
Yeah. So you have like a big texture, right? That's basically PNG or JPEG, right? Just a big bitmap, and then you have all of these little faces, all these little triangles. So if you want to, like, let's say, put a texture of this, wall onto a mesh, you need to know where each one of these triangles would be in that larger mesh, right? So it's a mapping of triangles and edges into this UV space. So it maps, like, could be large world spaces. In this case, our 10,000 by 10,000 onto a texture that is really width and height of 1 and 1. So it's a mapping between texture space and real space. So you can put surfaces on the triangles. So that's what we're doing here. We're basically going through and building the locations of each vertex and adding in their UV positions as well. And we're also adding the normals so we know which way is up, because we're a one-sided mesh. If we have the front facing the wrong way, or it calculated properly and half of the triangles are facing one way, half the triangles are facing the other, you'll just be able to see through like it was a sieve. So we're going through, and you can go through and check out this code if you like. This is some basic OpenGL vertex style code, just vertex wrangling and building triangles out of the vertices and calculating normals and whatnot. Now the magic here isn't doing the UV, isn't doing the normals, isn't making a grid of vertices. It's actually calculating the Z values of them. How do we calculate the height? How do we make the terrain look like a reasonable bit of terrain? And I consider this to be a fairly reasonable, like, water plus mountain looking terrain. It's reasonable for a planet-ish. What we use here is Perlin noise. Change terrain height. Here we are, this amplitude noise map. So Perlin noise map. So what we're doing here is using this particular noise function. So we're not using random here to randomize the height. That would just make no relationship between one vertex to the next, just pseudo-randomly picking a height. That will just look like gray noise. It'll look like grainy fuzz. Now with Perlin noise, it has some mathematical properties that are interesting to us. It has a global stochasticity, but it's coherent locally. So that means when you sample at area 2 inside the noise space, area 2.1 will be close to 2. It won't be radically different. But overall, there'll be a lot of variance if you look at it from a high level. So what does this get us? Well, this gets us a way of having a more continuous space of hills and valleys and smooth or curving things, which is really great for generating things like terrain. Did you know algorithms could win Academy Awards? This one did. Perlin noise won the Academy Award for technical excellence. It's been used from procedural fire to procedural terrain. If you look at the uses of Perlin noise in modern media, in CG, in computer graphics, in sound generation, it's quite well used. So we're using it here. So this is an example of how you can use a very technical concept like Perlin noise to make something like a mesh. And it also works in amplitudes and phases, so you can actually give it as, it's chordal. And that if you take octaves of it, or multiples of 10. I believe 10 is the octave in Perlin noise. I'd have to check that. Put a star beside that. I have to look that up. Then what'll happen is you'll have that noise be reduced and more fine, but still match the higher level noise. So every time you add another octave of noise, every time you multiply it by an octave, it still works well with what was there before. So basically what that happens is you have something that is overall like blobby and amorphous. Every time you add an octave, it adds more surface detail. Another octave, more surface detail on top of that. Another octave, more surface detail on top of that. And you can get as much surface detail as your floats have precision to handle. Much like fractals. You can zoom in on a fractal all day. And you'll keep getting detail until your representative power of your floating point numbers run out. Same with Perlin noise. So it's a really useful tool. And then we have our change terrain height, which is our fire 1 and our fire 2. which will go through and find which vertex we are closest to on the mesh, that the capsule the player is closest to, and we'll just raise and lower a type. We'll modify that terrain noise map. Okay, I think it's a good place to stop for now. I wanted to at least show you some interesting technical things today to counteract the more humanities style thing, to get your computer science brains flowing a little bit today as well. We have just a few minutes left. Does anyone have any questions on exercise 1 or 2 before we end today? Yes.
If we change like any basic mechanics of the game, do we want to list that just in GitHub, or is it fine to just cut it like commented out on the code?
Put it on the top of the README and comment it in the code. If you're chasing something basic about the game, you want your reviewer to know what you did and why, and to know it was not a mistake. We don't want to get you penalized for something that you intentionally did that's fun and interesting. Yes, and then you're...
Do we need to build the game?
Build a game. You should run the game and test it. You do not need to turn in a build. We will download your project and run it. That's sort of like what your reviewer is responsible for. Yes. How do you do the peer reviews? I will give you information about that. So basically all that it is, we have a template file for you in the GitHub repository. You just simply take that template, add it to the project you're peer reviewing, and put your information into it. It's pretty straightforward. But the act of doing it, putting in the file and filling the template straightforward, doing the review is harder. Yes.
When you look at your code,
Hey, I didn't dismiss you yet. Where are you guys going? Just kidding. Get out of here. Yeah?